Today is Tuesday, and I like toast. Or do I? In a 2003 study, students were fed a breakfast of either regular toast or beans on toast, and were then tested on their cognitive ability. And it showed that as the cognitive tests became more and more difficult, those who ate beans on toast actually outperformed those who ate regular toast. You could say they became a better person. Now this is really unlucky, because now I have to clean this up. But there's a chance that this accident never happened in the first place. And instead I just set this piece of toast down on the counter. Okay, what is this? Well, I don't really know. But what I do know is that whatever this is a solid. In fact, the kinetic energy of each individual particle that make up this is small enough that the forces of attraction between them keep the particles together, instead of just flying off into space. But what if we just had one particle, one molecule of this thing? And, well, because we just have one particle on its own, it will behave very differently than if it was with its counterparts, if it was all together. In quantum physics, a particle can both be excited and in its ground state at the same time. But once measured, only one of the two states will be observed. Almost as if the universe itself is rolling die. This exact same principle can be applied spatially, in the sense that atoms' electrons can orbit different energy levels at the same time, whether that's the first energy level or the ground state energy level. The atom as a whole can exist at entirely different positions at the same time. So in a way, one atom could exist over here, or could exist over here at the same time. It's only once we observe the atom that we can truly identify which state it's in. So in a way, I could be making this video in some random forest miles away.
Now, this is the cool bit. If I close my eyes, I cannot see. And when I cannot see, I cannot observe. And it could be interpreted that I am in a quantum state, with my superposition either being here in a forest,
Or could be there in my home kitchen.
It's only when I open my eyes when I can observe. And it's quite clear that I'm in a forest right now. But when I do this, I have no idea where I am.
Clearly, I'm just in the studio with my toast. The same idea with superposition can be applied to all 475 sextillion molecules that make up this one slice of toast. And right now, I know where it is. I can see the slice of toast. I can smell it. But watch this. When I do this, it could be anywhere in the entire universe. And by this very definition, how would we know that toast is real in the first place? How would we know it exists at all? And we don't. Really. I mean, how would we know that toast is real in the first place? It's entirely possible that toast as we know it doesn't exist. And it is just a completely random collection of completely random atoms that just so happen to exist from a quantum state and is composed of every single element needed to make toast as we know it in a near enough ratio 100% of the instances that we could possibly observe. And we actually have no idea how to answer that. I mean, it is entirely possible. The odds are stacked woefully against you, but it is still entirely possible. And with that, I'll see you in the next quantum state. I was going to eat this, but it is a bit cold. It's been like 2 hours recording this stupid video. Does toasty exist? Of course it does. Of course it does.